Hi there and welcome to the final workshop of Topic A, Workshop 8, where we're going to find the MP for Wairarapa's ute, among other things. In fact, it's his old ute, he's sold it now. So let's load in this data. So we're using data today from Waka Kotahi, so the New Zealand Transport Agency, and it's just a subset of the data. So they have a very large data set, it's about 1.1 gigabytes. And so we just have a small extract here of 849,000 rows over 12 columns. I think the actual data set has about 30 or 40 columns in it. Again, you can grab it yourself if you wish. Just Google for the New Zealand Transport Authority fleet data, and you can download the lot if you wish. So we filtered it down to just cars and vans, and utes and whatnot. So you can see we've got a number of columns. We've got the colour of the vehicle. We've got the body type. Is it a utility vehicle like a ute? We've got how big the engine is, so the CC rating. So this is the rating in cubic centimetres. We've got the gross vehicle mass for some of them. Some of them are 0, so that would presumably be unknown. We've got the make. We've got the model. We've got the motive power, so is it petrol, diesel, or presumably some sort of electric. We've got the number of seats, we've got the power rating, which is obviously sometimes filled in and sometimes not. 0 presumably is not, is missing data. We've got the TLA, so this is the Territorial Land Authority, so Territorial Authority. There's about 75 odd across New Zealand. We've got the vehicle type, we've got the year as well. And we've got that for 849,473 vehicles. So we're going to answer some questions based on this. So the first thing we're going to do is reproduce a plot. So let me bring up the actual plot that we need to reproduce. So we're wanting to reproduce this chart here. So we can see that what we have is that we have the years across here. So this is some sort of a year variable. And we've got the percentage of cars and vans up here that are each colour. Okay, so to produce this plot, what we're going to need is we're going to need a data set with the year in it, with the percentage of cars and vans, and with colour. Okay, so let's jump back to our studio. So the first thing we do is fine-tune it just to cars and vans, and we remember that we had the vehicle type available for that. This one here, so we're going to just filter it down to passenger cars and vans. So that's the first step. So we'll run that. So you can see that cars and vans are most of the data set, 719,000 observations. And the next thing we're going to do is we're going to summarise the data by counting the number of cars and vans by each colour for each year. And then we're going to convert them to proportions. And we're doing that because our chart has those requirements, right? We've got the colours, we've got the year, and we've got the percentage of cars and vans of that colour. So you can see that over time, the proportion of blue cars reduced and then went back up again. Green cars are less popular now. Purple cars had was a bit of a thing in the around 2008. Red cars have always been a thing, but were less of a thing around the same time that purple cars were a thing, and so on, right? See, the orange cars are making a comeback. Gold cars had a thing in the early 2000s, and now it's gone back down again, and so on. Brown cars in the early, about 2012, that peaked, and so on, right? So we need a data set with colour, with year, and with the percentage of cars of each colour. So to do that first, what we're going to need to do is count the number of colours by year. So the number of cars and vans by each colour by year. And then once we've counted them, we could convert those counts to percentages within year, right? Okay, so we're going to take our cars and vans, and we are going to group by our vehicle year, vehicle year. We're going to use tab complete, so I spelled it correctly. And perhaps we might be group by our color as well, and then we could count them, right? So we could summarize. Right, so there's the counts of each year. We have each color and we have the number of cars. So here's 1991 starting there. Okay. Now you could also do this with the hint. So instead of grouping by two variables and using the summarize could be done with a count as well, right? So we could instead just group by vehicle year. I'm not quite sure why the and then count. Right, so you remember that the count does a group by and does the summarize for us. So we're going to count basic color, and that will give us the same thing. That's why the autocomplete wasn't working. Cars, vans wasn't our data set. Cars, vans was. Okay, so we get the same data set, right? Instead, we've got N instead of count, but the same thing. We've got the same thing. So right, option 2. Right, same thing. We might use N equals N here so that they're exactly the same form. Okay, so that gets the count, and now we want to convert these to proportions by vehicle year. Right, so within vehicle year, which we're grouped by, we want to convert these numbers here to proportions. So what we might do is we might mutate and go proportion is just equal to N divided by the sum of N. Right, so we could compute, I guess breaking it down, we could compute the total, would be the sum of N. Okay, so that's the total by year. All right, so for 1990 we've got 14,214, and for 1991 we've got 15,000, and so on, right? It goes up because more and more cars are registered each year. This isn't always the case. Some years it does eventually go down, but over recent years it's always gone up. More and more cars on our roads. Okay, and once we've got the total, of course, we could then mutate and figure out the proportion would be N over the total. Okay, so that's the proportion of each colour within the year, right? So these add up to 1 within the year. Okay, so we could call that, and then so we'll call this proportion of colour. Okay, so we can spit it out so we can see it. Right, and this is now what we need to chart, right? Because what the chart showed was it showed the vehicle years and it showed the proportion for each colour. So let's get the basic proportion plot up and running. So we're going to do a ggplot. We're going to take our data. It's going to be equal to the prop colour by year that we've just computed. And then let's have a think about what geometry we need. So it looks like a line chart to me. Right, we've got a line here. So let's use a line chart. And our mapping is going to be, well, we want year on the x-axis. So what's that called? That's called vehicle year. And the y is going to be our proportion. So we could try that for a start. Okay, and we get this nice looking spiky chart. And this is because we've also got all of the different colors here, right? So we could, for example, color by color, right? And if we did that, we would distinguish the colors, and we can see we've got all of the information that we need on for the chart. Except in this case, instead of coloring, we want to facet by that, right? So we're going to facet wrap vase basic color. There we go. Basic plot done. Let's compare it to the one we've got on the web. That looks very similar. Okay, and the next thing we're going to do is we're going to fine tune that plot with some labeling. And we could also do theming on it as well. So what we noticed from the one on the web is that instead of proportions here, we've got percentages. We've got some labels that we need to use, and we've also got a different theme. So let's knock them off one by one. So we're going to start with the axis labels. So what we want to do is we want to convert the proportion here to percentages. So what I might do is just Google y-axis percentage is ggplot. How can I change the, look, I've searched for this before, the y-axis figures into percentages. Right, so this is exactly what we do. Here we go. There's the answer. Copy and paste that. So we're going to use the scales package. So scales percent, and the other way you can do it is percent format. Okay, put them in percent. Perfect. And now we can perhaps do our labels. So what were our labels? Let's go back and have a look. So it looks as though the y-axis is percentage of cars and vans. Okay, and we've got a title, The Rise of Orange and Demise of Brown and Gold. And what else have we got? Car and van colours in New Zealand as a subtitle. Okay. The other thing I notice is here I've got vehicle year on my x-axis, whereas in the chart I don't have anything on my x-axis. So to turn off the x-axis label, we're going to just say x equals null. So null is short for nothing at all. So notice that that's different than an empty label. An empty label will also appear to work, but notice I've got a bit of white space here. Perhaps it's not something to really worry too much about, but null gets rid of the space for the label. So empty label still gives me a label, it's just empty. So the space for the label is there. Null turns it off. So that's the difference between those two. And now we've got the chart pretty much the same. The only difference is that this one has a different theme. So perhaps I could Google ggplot themes. Here we go. Click on complete themes. Do I have an example? Let's have a look. Oh, here we go. Perfect. So let's look for one that sort of matches. I need one with some faceting. Here we go. That one looks very similar, doesn't it? Similar colours. Let's go back and have a look. Yes. So that is theme BW. So we could try that. And there we go. Same chart. Okay, so the process when you're reproducing a chart is essentially come up with a base chart that basically gets the data. First of all, get the data in the form that you need. Secondly, get the data onto a chart that's somewhat similar. And then tune the chart. So get the faceting right, get the labels right, get the axis labels right, and then worry about the look at the end, so things like the theme and so on. Okay, so the second question, we're going to look at, are Ford Rangers a rural phenomenon? So, of course, the Ford Ranger is a gigantic ute. Utes have been getting larger and larger over time, so we can see we've got 31,000 utes in the country, and we've done a little bit of, these are new utes, so after 2015, and we've done a little bit of mutation here to pull out the Rangers, and the reason is that the Ford Ranger information is in the model variable and the make variable. So we need a Ford Ranger, so we need the make equal to Ford and the model equal to Ranger. So the single ampersand here is for and inside an if else statement. Okay, so essentially what this is doing is adding a new column type, right? And you can see that some of them are Rangers and some of them are others. So the ones that are Ranger are the ones that are have Ford and Ranger. I guess we probably could have just picked out Ranger from the model column, I guess. It's probably enough, right? Because it's only a Ford Ranger. Okay. Calculate the proportion of utes that are Ford Rangers for each TLA. So we've got territorial authority. So let's have a look in our data, just so that we know what to pull out. Which column is this? Okay, so it's actually TLA. Perfect. So we want the proportion of Ford Rangers for each TLA. So we're going to take our utes and we're going to group by our TLA, and we need to count the number of each type. So we can see here that we've now counted the number of others and the number of Rangers in each district. So there we go. So you can see obviously in Auckland there are many more vehicles. And now we want to convert this to a proportion, so we could do exactly what we did before, right? We can compute the total within, so notice that we're still grouped by TLA. So we're going to compute the total within the TLA, which is going to be the sum of N, so that's the total number of utes in the TLA. So you can see that 252 plus 107 is 359, and 5,979 plus 2,482 is 8,461, and so on, right? And then proportion. Okay. So we could call that prop Rangers. And then we'll spit it out so that we can remember what it is. Using only the proportions that correspond to Ranger rather than other, produce a bar chart for the proportion of Rangers across each TLA. Okay. So let's have a go at this. So we want only the proportions that correspond to Ranger. So we're going to take this prop Rangers and we're going to filter it down to just Ranger. The idea is that if we know the proportion of Rangers, then we know the proportion of others of non-Rangers, because they add up to 1, right? So we're going to take our prop Rangers and we're going to filter where the type is Ranger, right? So that gives just our Ford Ranger numbers. And produce a bar chart across each TLA. Because it's a bar chart and we have the length of the bars, we're going to use geom_col. And we're going to map X to the TLA and Y to the proportion. Okay. So there we go. There's the proportion by TLA. Now notice that putting TLA on the x-axis here is probably a dumb idea, because there's a lot of them and some of them have very long labels. It's probably best to switch the axes here. So I'm going to switch the TLA to the y-axis and the axis to the... so there we go there. And then I might want to convert prop to percentage. So I could use scale x continuous with labels equals scales percent format. I can do label percent as well, I think. I'm not sure which one is the correct one to use. Let's look at the help and see if there's one that's preferred. Doesn't seem to say. Right. I think the label ones are specifically to produce labels for ggplot, whereas the percent format and so on can be used on anything, I think is the idea. Right. So now what we might want to do is notice that this is ordered alphabetically. And an alphabetical ordering doesn't necessarily make sense here. I mean, perhaps you could order by north to south or something. I mean, alphabetical ordering does help you find what you're looking for, if you know what you're looking for. But that's the only real advantage of it. And in this case, when we're answering a specific question, which are Utes a rural phenomenon or not, we might want to actually order by the length of the bars instead. Put the bars in order, because then we can just pick out the ones that are biggest or smallest based on which end they're at. Okay, so what we could do from lecture 8 is we could reorder the TLA using factor reorder. So we're going to order the TLA variable by the proportion. And when we do that, nothing happens. This is subtle. Something has happened, but the problem is that we're grouped by TLA. So the order is being executed within group. And of course, there's only one TLA in each group. So ordering it by prop is not doing anything in this case. So we'd need to ungroup first. Now, when we chart that, it will reorder them. Okay. So the last thing we might want to do is clean up the labels. So we could perhaps x equals percentage of Utes that are ranges. Perhaps we'll turn y off. And then we really need some more space here, don't we? So what we could do is we could change the figure height to 10 and the figure width to 7. So these are ancient units called inches by default, but that'll flip it around and now we can see a little bit better. We could also change the size of the font, I guess, down a bit. So you can see that the TLA with the most ranges is the Chatham Islands, but the second most is Christchurch City. Then we've got some that are clearly rural, like the Huranui and Gore. So this is the bottom of the South Island. But then we've got Central Hawke's Bay, so that's rural as well. Mackenzie District, that's rural. And then Invercargill City, which I guess might be rural. I mean, it's the town, but I guess potentially there's some of the ranges are registered in the city, but Auckland's quite high. So's Nelson, so's Hamilton, so's Dunedin. Okay, and the ones that are lowest are places that are actually that are really rural, right? So Ruapehu and Waimate and so on, Kawerau and so on and so forth. So unclear that this is actually a rural thing. So it seems as though there's a bunch of people in Christchurch in particular, and also a bunch of people in Auckland that have ranges and those are clearly not rural locations. So perhaps ranges may be a urban thing as well. as a rural thing. And part of that is probably the tax incentives, right? So because Rangers are a utility vehicle, there's a tax write-off for businesses. So I have a friend in Christchurch, for example, that works at a meat plant. He's one of the managers there. But as a manager, he doesn't need a ute, but he's got one, and it's because they could provide a fancier ute for the same. That was more expensive because there was a bit bigger tax write-off. So he doesn't need a ute, but he's got one. Right, so use Google to find out who the Member of Parliament for the Wairarapa is. So the goal here now for this last question is a bit of a fun one. We've got all this data on cars and of the fleet data, so which contains utility vehicles, cars and vans and so on, and we're going to try and see if we can find one particular row. Okay, so in case you don't know who the Member of Parliament for Wairarapa is, we could Google that. So let's put that into Google. So the Member of Parliament for Wairarapa is the Honourable Kieran McNulty. So let's grab his name. Okay. And now we're going to use Google image search to find a picture of the ute. Now the idea is that we want the registration, because inside our fleet data we don't have the registration of each vehicle, but we do have a lot of information on the vehicle. And so if we have the registration, then we can look up that registration on a government website, which summarizes information about that car, which is used for if you're purchasing a used vehicle, for example, and you want to find out information about the car, like how big an engine it has, what type of vehicle it is, what year the vehicle is, and also things like the CO2 emissions and so on. You can find that out. So let's find his ute. Now we want one with so we're going to use Google image search. So there he is, if you haven't seen him. So Kieran McNulty ute. So here we go. Here's his ute. In fact, it's an old vehicle because he's recently swapped his famous red ute for a new one, which is rather less exciting. So we want one that's going to have the number plate on it, the registration plate. This one might. Let's have a look. We can just see it at the edge there. Not quite. How about this one? Okay. Oh, here we go. There we go. GCU 805. So that's his classic ute. So let's GCU 805. Did I remember that correctly? GCU 805, yes. Okay. So we're going to look up the registration on rightcar.gov.nz to find information about that car. So GCU 805. And here it is. So it's a Mazda B2500 from 1997. Let's make a note of that. From 1997. It's red, obviously. It's a double cab pickup. What else? The engine is 2499. And I guess the power is 64 kilowatt, and it's a 5-gear manual, and it's diesel, isn't it? Right, let's see if we can use that to find the row that we need. So we're going to take our fleet data and we're going to filter our vehicle year. It's going to be 1997. Right, so we still get 24,000 rows. But what else have we got? Well, we know the make is Mazda. That gets us down to 1,000 rows. We know the basic color is red. So that gets us down to 142 rows. We know the body type is utility. Right, so ute. So that gets us down to just 14 rows. We know that the model is a B2500. So we can use that as well. So there we go. We've got 12 B2500s in the data. They all have the CC rating 2499. So that's not particularly useful. Can't filter on that anymore. Number of seats though. Some have 5, some have 3. The power rating's all the same, so we can't filter on that. We can use the TLA though. So presumably it's registered in Masterton, which is in the Wairarapa. So let's filter on that. There we go, we've got just 2 of them. And we see that one has 5 seats and one has 3. And looking at the photo, so well, looking here, we've got 5 seats. So we know what it is, and presumably the photo would tell us as well. Right, so number of seats is 5. There we go. So that is his Kieran's old ute. So lastly, I'm going to knit that document just to make sure that I haven't made any mistakes and it's all reproducible for us. There we go there. So let's see our plot reproduction. There it is there, that looks great. Here's our plot from the ranges. Obviously we could tidy this up further, add a title, perhaps make this lowercase, so you could look at strut to title for that. For title case, perhaps I'll do that really quickly. So we could do some more mutation. Perhaps before we reorder it, we could say okay, so that makes it look a bit nicer. We could add a theme. There we go, and so on. We could also perhaps notice that this starts at, all the bars of course start at 0%, but the axis actually starts further over. So that's because by default ggplot will add some white space. We could add a title. So when we go scale x continuous, there's an expand argument. So by default on a continuous axis, ggplot will expand the axes out past the range of the data a little. And so if you set expand to 0, 0, like that, C0, 0, that'll add no space left or right. So you can see it scrunches it up a bit now. So let's knit that. I should clarify this. Utes that are ranges. Right, our proportion is out of utes, not out of all vehicles. I guess we could redo it for all vehicles as well, if we wanted to. Our title's a bit long. Perhaps we could make that the subtitle. I could change it with the theme, I suppose, but there we go. And there's our single row for Kira McNulty's ute.